All right, good evening, everyone. Welcome to you all, and thank you very much for joining us this evening. Before we begin, just a few house rules, please. If you can just please mute yourself and just ensure that your notifications are off. If you've got any questions, please jot those into the chat box above on the text box above. You can just see a Q&A. Just please jot your Q&A questions in there, and we'll be addressing them at the end of the session. Tonight's session is a little different. You would have seen the first slide is a QR code. Let me just display it again. You've got a QR code there with a question that is posed to you. If you haven't had a chance to scan it, please do so. The idea is to have this presentation to be more engaging and discussion driven. So we will be answering and looking at the different answers to this question at the end of the session. Throughout the session, you will be getting a presentation as well as mid-presentation, there will be questions that are posed to you. So please do engage so that we can have a fruitful presentation. All right, just common questions. These a copy of these slides as well as the recording will be shared with you in about 2 or 3 days after the presentation. You will also be getting a certificate of attendance. We will have another QR code displayed again towards the end of the session. Please do scan that. It will take you to a survey that you need to complete. Thereafter, you will be getting your certificate of attendance. All right, so my name is Busisiwe Matewu, and I'm going to be your host for tonight. Tonight's presentation is going to be presented by Mr. Samkelo Nene, and the topic for tonight is, what do engineers actually do? So I'm going to hand over to Mr. Nene, your presenter. Thank you very much. Mr. Nene, over to you.
Thank you, Mrs. Matewu. Let me just take control. Okay, I have taken control. Good day to everyone once again. Thanks for joining us for today's webinar, which is what do engineers actually do? Okay, so today, as Mrs. Matewu said, it will be more of a discussion. There will be questions that will be posed throughout the webinar. Let me not say presentation. It's a mix of both presentation and also questions, and also feel free as well to pose questions on the chat box, and I will then answer as we go along. So these are the contents for today's webinar. So we were looking at what is engineering majors, and later on then we will look at the applications in terms of career and also the impact of engineering to civilians, and then we will conclude our webinar. Okay, so starting with engineering. So engineering is simply application of science and mathematics to solve a solution. So these are some of the famous codes made by some of the world famous people. We see the late Queen Elizabeth II, when she stated that at heart engineering is about science to find creative practical solutions. Okay, the keyword there, it is practical solution. So engineering, it's about practicality, it's about doing it, it's about making, and it goes very well in hand with what Albert Einstein said, that scientists investigate that which is already is. So in essence, what he's saying, that scientists, they then investigate the properties of your elements and materials, and then engineers uses that or applies that knowledge then to create something that has never been. So in essence, engineering is simply creating something, okay, which is practical, or to solve a challenge, or to bring solution. And then at the top there, you can read the one by Elon Musk. That is the magic that exists in the world. So again, based on what Albert Einstein is saying here, it is in a way sort of a magic, because you're creating something that has never been. Okay. Hence the word innovation tends to go along with solutions that are brought by engineering. So Engineers, as we've already established, that they bring solution. So they identify problems that we are facing or challenges that we face, and then what they then do is then they weigh solutions, and also before weighing solutions, they investigate what's the cause, what can be done. So what can be done, that's where the parts solution comes in, and thereafter then they evaluate the solutions. And in their approach, engineers they tend to use systematic processes and also the working teams. So what you'll find throughout this webinar, you'll find that, or rather what you'll realize is that engineers um, or engineering is sort of like cross-disciplinary. So most of the time, if not all the time, you'll find that different engineers work together. Okay, you'll find mechanical, we're working with electrical and civil and so forth. So hence sometimes they will say the interdisciplinary of engineering because all these disciplines they come together to provide solution or solve challenges. So here are some of the well both engineering majors and also some sort of combination or speciality of engineering, which we'll also cover once again in one of the following slides. So starting with the engineering majors, so we have your civil, we have your industrial, we have your electrical, we have your mechanical, chemical, and that's pretty much when it comes to the the oldest and the overall engineering. So with industrial, some people may argue that industrial is sort of mechanical because again it deals with optimizing processes uh, as mechanical also deals with that. So sometimes people would prefer to just use civil or rather refer to civil, mechanical, electrical, and chemical as sort of like the fundamental engineering, and then obviously then the rest branches out from that either as a specialty or a combination of the fundamental engineering. So you have your electronic, which is then a specialty or a sub sector of electrical. So and so is computer as well, which is a mix of computer and your software or computer science and your aerospace, environmental, petroleum. These are all specialty which we'll cover just now. Okay. So starting with mechanical engineering. So mechanical engineering. Does anyone know what is a mechanical engineering or have any idea when they hear mechanical engineering? Feel free to post because apologies, I will also ask questions as I present. So mechanical engineering, does anyone know? Feel free to comment or post on the chat box. Mechanical engineering. I know most people, when they hear the word mechanical engineering, they think of cars. However, mechanical engineering is more than automotive, okay? So in essence, mechanical engineering, it's the science, okay, of designing, producing, and operating moving machinery, okay? So we see here guys working with your gears. So it can be gears, it can be levers, those with these dynamics, these movements. And also, you find that the mechanical systems that are used to convert energy you will see it even in application such as your power and energy systems where we use your turbines to convert the wind energy into mechanical energy and then electrical energy you also find in your generators that's the power and energy sector where we then convert the mechanical energy into electrical and so with systems as well such as your pumps for heat, right? And the key word is to think of design, build, and optimize. Again, I also mentioned that even industrial as well, they also then focus on optimizing. Hence, some people may say that industrial, in a way, it's a subset of what mechanical engineering. And then some of the subjects, mechanical engineering uh, students mechanical engineer, okay, students will be the better word to use than learner, is then statics, your dynamics, thermodynamics. They also learn about materials science or materials engineering because obviously the machinery that they design and operate must have properties. that will enable them to perform effectively, and also they learn about the strength of materials. They learn also about even the flow of heat, which is thermodynamics. It's quite a broad engineering, mechanical engineering. And then moving on to chemical engineering. Again, chemical engineering is also one of those engineering, just like mechanical. Mechanical people will think of cars, automotive, which is a part of mechanical. Same thing with chemical engineering. When you think of chemical engineering, we think of like your basic, your chemicals, extraction, and that's it. However, it goes far beyond that. It goes far beyond your typical commodities or special chemicals. Okay. So I think there's a comment, but I'm still waiting for the chat to load. So with chemical, even things like we use every day, you know that to convert materials to your cottons, to your wools and your plastic, that's also part of um chemical processes. So it goes beyond your typical commodities and so forth. And again, it's about creating processes, and not just processes, even creating plants as well to conduct those processes, to convert those raw materials into useful materials. Okay. And chemistry, I think the word chemical gives it away. There's chemistry involved, a lot of chemistry involved, and also thermodynamics as well is also part of it. Because now, for example, when it comes to your oil and petroleum, you speak of a boiling point, right? That's using now your heat, and then also reactor design, reactors where they perform these conversions. So I see that Mrs. Matewu also rewrote the first question. Okay, okay. So please do answer the question. I'll just continue because I thought it was a comment. It was a comment or a question, but I'll continue. So moving on to electrical engineering. Electrical engineering. Uh, again, uh, it's one of I think all engineering. I may be biased because I'm electrical engineering, or rather, my background is in electrical engineering. I may be biased. Um, as I've said, with mechanical, people often think about automotive, and then with chemical, people often think about, the typical chemicals and commodities. However, with electrical engineering, I'm not sure if it's the load shading, but we are familiar that, it's more than our domestic installation, so that your lighting, it involves also things like the power grid that supplies um, industries, commercial, and also when it comes to domestic installation. So it's one of those engineering that is sort of out there that we see and also interact with, even at our places, homes, or apartments. So in essence, it's the control of electrons to do useful work, and also uh, if you look at electrical engineering, or the history of electricity, that it's founded on magnetism. Okay, it's one of the forces um, that we can relate to, other than your typical gravity. So if you think of gravity along those lines, magnetism is one of the forces that is part of our reality. So electrical engineering then uses that force, then to move the electron to do useful work. Again, electrical engineering is also broad. So from telecommunication, from light electrical engineering, so that's being your appliances, telecommunications, until you get to your heavy electrical engineering, that's being your power systems and so forth. And then software engineering, if you think of coding, developing, okay, so the systems, the engines that you are using online, so there are software engineers behind that, to then write program for those engines, for those program as to what to do. Okay, so that's what typically software engineers do. It's largely algorithms, data structure. They even get into data engineering. That's what software engineers. And this was by coincidence, by the way. If you put these two together, electrical and software engineering, you end up getting what we call computer engineering. So these two, in a way, then give, I will say, birth, but it's the combination of these two lead to computer engineering, where electrical addresses your hardware and then software engineering addresses mostly the software part of computer. And then coming to civil engineering. So civil engineering also, I think it's one of the engineers that we see, we interact with every day. So it's one of the oldest engineering. So does anyone know why civil is civil engineering? Anyone know? You see, with mechanical engineering, we're using mechanical systems, and then with electrical, it's electricity, electrons, and then chemical, it's chemical conversions, or rather converting raw materials through chemical processes. However, with civil, why civil is called civil? Does anyone have any idea why civil is civil? I'll just give everyone a minute or take a guess. If we think of the word civil comes from civilians, right? Civilization. So civil engineering, or the word civil engineering, came about to distinguish between engineering for civilization, or for civilians rather, versus engineering for, back in the day, it was it was military engineering, it was naval engineering. Back in the war days, we had military engineering, we had naval engineering. So this was a sort of engineering that deals with civilians, advancing civilization, building bridges, building dams, and also things like control of water reticulation, back for agriculture and so forth. So it's one of the old engineers. So unlike mechanical, which deals with moving structures, largely, if you look at engineering projects, they are static, right? If you look at the building example, the buildings or the cities, today they are one of the biggest civil engineering projects. If you think in the past, you think of the pyramids of Giza, which are also one of the biggest civil engineering projects in the history. Okay, so it's more about infrastructure. Also, civil engineering is broken down into your surveying, which deals with measuring and inspecting the land on which the buildings will be standing. And then we have, from surveying, we have your structural, which deals with ability of those building, okay, to withstand environmental effects or impacts from such thing as your earthquakes. And then we also have, as well, uh, architectural, which deals with designing those structures and then those design. And then we can even go further to your railway or transport, because if I go railway now, I'm just even going to a niche. But let's just say transport engineers, they'll deal with railways, deal with roads. So it's one of those, again, engineers that is out there that we see and interact with every day, and also very, very important when it comes to, I know, in previous webinars, and also sometimes I tend to say electrical, like in bias, is the most important because it drives the economy. And so is civil as well, because imagine without roads, imagine without railways, without infrastructure. So it's also one of those oldest and also important engineering. Then we have also industrial engineering. So this is largely about optimizing processes, and also when it comes to manufacturing systems, efficiency, and all that. So when it comes to then industrial engineering, some of the things you learn economics rather, and then your data processing, and then yeah, that's pretty much. I see with the previous, about the last two engineering, I didn't mention the majors. So just to touch on civil again, structural design, your mechanics of materials, and also fluid mechanics, and Just to quickly go over with software, I did mention programming, algorithms, and then for electrical, as I mentioned, electromagnetism or magnetism are big, and also signals and system. So that will be when it comes to control system, because as much as we build this system, we must also have systems that will uh, then make sure that they are protected. So that includes control systems. And then coming to the second subtopic, which then is on majors. Okay, well, we're still on majors, however now we are on specialties and combination of engineering. Okay, so if you look at mechatronics is a combination of two engineers. Can anyone guess on the chat which are those engineering? In fact, it's more than one, but based on the word, at least two engineering has uh, been combined to make mechatronics. Can anyone guess on the chat? When you hear the word mechatronics, which engineering rather, do you think? Thank you, Mr. Mafumo. It's mechanical and electronic. Okay, it's mechanical and electronics. So if you think the likes of robotics, that's also a specialty under mechatronic. You see, we have a combination and specialty under both electrical and mechanical. Okay, if you think of mechanical, so mechanical obviously will bring the structure part of it, and also the if you look at the structure, then material properties will matter that you are using, and then electronics then will bring the control part of the your typical robotics or robot. Okay, and then we also have material. So material again, uh, there's material science, there is also material engineering, there's also cross-cutting when it comes to engineering, because it's also one of the majors under mechanical and also under civil as well when you obviously deal with the materials for your structures. And then computer, even here it's computer hardware, then it will be under computer engineering. Again, we have what electrical and software engineering, which brings both software and hardware. Okay, and then we have aerospace. So aerospace again, mechanical is there, electrical is there, but mostly you find aerospace is about your aerodynamics, aeronautics. So if you think of jets, if you think of aeroplanes, that will be your aerodynamics engineers, and then aeronautics. You think of your rocket. You know, if you think of NASA, all these um, rockets, it will be aeronautics and your aerospace engineers, obviously working hand in hand with control system, with mechanical, with electrical, and so forth. And then there is even also bio, okay, biomedical, sometimes bioengineering. So biomedical will be a subset of bioengineering. So basically where we use biology and engineering. Okay, so uh, we build systems that will support biological processes rather. So it can be even be things as like designing and making prosthetics to replace body parts. Okay. However, if you wanted to go into genes mutation, then you will have to have also a background in biology, not just math and science, as we saw so far that engineers largely use math and science. However, if you want to go further into biological engineering, biomedical engineering, like gene mutation, then you might end up then, or rather, you are also required to have also a background in biology. And then there's also nuclear engineering. Again, nuclear engineering, it's about then using nuclear energy, whether for power plants, for weapons, and also nuclear. What is not out there because most of the time, or what people know about nuclear is for energy. But before energy is nuclear weapons, and then energy. However, nuclear is also used when it comes to healthcare as well. When you think of the nuclear isotopes, it's also used, is applied in health sciences. So again, that's a specialty. To be a nuclear engineer, so you'll have an undergrad in engineering. So from then you branch out to nuclear most of the time at the master's level, where you do then a master's in nuclear science or engineering to become then a nuclear physicist, scientist, or engineer. Again, it's a specialty. It takes some years for you to get to that level. So let us discuss based on what we've covered so far. Okay. So if you were to become an engineer tomorrow, what would you want to work on? What or to even make it easier for you, what problem in South Africa would you like engineers to solve? And also what problem, or should I bring it to you, what problem would you solve then if you were engineer tomorrow?
You guys are welcome to raise your hands or just type in the chat box.
Thank you, Busi.
Uh, Thank you very much, Mr. Nene. I think if I can participate on my side, I would solve the electricity problems.
Literacy problems. So
Yes.
now the literacy problem, that's great because we still do have them. Uh, I know people they say no longer we no longer have load shedding, but again we have communities where they have what load reduction, okay, where their demand uh, surpasses the supply that's coming to those communities. So now and then the distribution centers will then shut them out. So we still have issues when it comes to electricity. And also, if you look at our electrification rate, it's not 100% or even near. If you look at like your typical Morocco and your Egypt, almost everyone has electricity, whereas with us, I think we are in the 70s, 70%, and so forth. So we still have a long way to go when it comes to electricity, especially for people in the rural areas or remote areas. Majority of them still do not have electricity coming from the grid. So it would be good to explore alternatives such as remote solutions, your solar panels and your wind. So yes, that's a great thing to do. Theft of railway
Thank
tracks.
yes.
Yeah, yes. Thank you, Wusi. I see Mr. Mafumo, theft of railway tracks, which is a challenge that we have, when it comes to railway systems. Railway systems are the backbone of economy. Moving off raw materials, you find that, sometimes it even cheaper to export raw materials than to move them around the continent or the SADC, because we don't have railways that are functioning, even though now, obviously, the likes of your Transnet, they are working hard. Uh, and sometimes when you talk to them, they talk about these solutions they want to implement. For example, like they're even going as far as wanting to use the wall to protect the railway, which I think for me it's in a way impossible to protect the entire railway tracks using the wall. So I think it's one of those pain points. It's one of those pain points uh, that we face as a country when it comes to railway tracks and railway systems. However, now with the private sector being brought on board to work with the public sector, as we did with electricity by bringing the private sector to work with the public sector to address the issue with load shedding, generation. I think since now they've been bought as well, when it comes to railway system, we will come up with innovative solution. But that would be a great thing to do as well, Mr. Mafumo. It remains a pain point when it comes to our economy. Let me go down. Road infrastructure. Thanks, Mrs. Matewu. Yes, that too as well. You you see, transportation is very, very important. It's very, very important because again, we want to industrialize as a country. We want to create more jobs. So if our infrastructure is worn out and is not ready, it then becomes a hindrance when it comes to our path to industrialization. So these are some of the important um, things that we have to look into as engineers and also critical challenges that we have to address. And then also, again, water challenges as well. So I see a lot of civil. Thank you, Ms. Rudman. So these are a lot of civil. You see how civil is important. Civil is very, very important. It's very, very important because again, just as power, we need power to have the light on, to produce, to manufacture, to run businesses. But at the same time, once we've produced whatever we're producing, those products, whatever we've manufactured, and then we have to then export, or move around some of the things that we produce in Gauteng, what we use N3, right, to take it to the port in Durban and then sell to the world. So if our infrastructure, if our road, are not, rather are worn out, that affects that, and also water challenges as well. In Gauteng, I think we lose about what, is it 60 or 40% when it comes to water losses, which then leads to water outages in some areas. So these are some of the challenges that we face as a country. That's true, Mr. Mafumo. That's true. Unemployment can be solved by engineering entrepreneurship. Okay. Engineering entrepreneurship. Again, you don't have to start a business because again, that may take some time, but just to have an idea that also can make you an entrepreneur, you know. We used to call them something, I think it was social entrepreneurs. Those entrepreneurs who don't build businesses, however, they come with ideas and then they sell the ideas to businesses or to people who have then the capital, to bring those ideas into reality. So we need people who are innovators, who think innovatively, come up with these ideas to address these challenges. So we'll continue with that as we go along. Feel free to post the your comments, and if you have any questions, feel free to post that as well. Yes, that's true, Mr. Mafumo. Massive water leakages. Even if when you go to Johannesburg, even in the CBD, you see that there's just water leakages. Roads are broken, and sometimes you think it's an oasis, but it's not an oasis. It's a leakage that's obviously started underground, and then the water now is at the surface level. So yeah, we have to solve these challenges. We have to come with solution and ideas. So moving on to careers and impact. Okay, so we've already touched on some of these while we were discussing which challenges we would like to solve. So this includes roads, as we see here, the roads. So obviously we want our roads to be safer, and also the transport that travel on the road. We don't want your transport or your car, even the logistics transportation. We don't want it to be worn out due to um, infrastructure challenges. And then also, so that's part of the civil when it comes to maintaining roads, building road. You see, Sunroll is busy, especially in these national roads, is busy extending the roads and also maintaining it. And then when it comes to the electrical side and mechanical side is then to then build or design and build safer vehicles. And obviously, then if you speak of climate change, reducing emission, that will be then building cars that will be climate friendly or environmental friendly, that will produce less emissions, your typical hybrid cars, electrical cars, and so forth. And then when it comes to sustainable energy examples, so starting with your solar, again, your solar energy. So let's start from material engineering, mechanical engineering, and then from then it then goes into electrical, where electrical works along with optical engineering. So using the irradiation of the sun to then generate electricity, which is then the flow of electrons. And then if you look at your wind turbines, again, that's mechanical in action, which converts then the wind energy into mechanical, from mechanical into electrical. And then so biothermal, yes, we use heat pumps, which is mechanical. And then again, think of biofuels. We take your even algae as well. We can use but apart from that, we can use your sugar cane, even things like your wood chips basically to then to create or combust to have biothermal energy, and then we can use this energy then to power plants, or rather as plants then to power or to drive generators to create electricity. And then if you look at your hydro energy is about gravity. So now, even though we end up with electrical, which I said we use what? We use magnetic or magnetism, which is one of the forces that is part of our reality. And so is gravity as well as part of our reality. So we're using gravity. So water, for example, if you think of your pump storage where you move water between two bodies, and in that process you use turbines then to drive generators, okay, to produce electricity. So if you think of your hydro, again we're using gravity, mechanical, then we end up with electrical. And the last one, let me just make the screen big. Apologies about that. The last one below, the wind energy. So I'm struggling to see this part here. Apologies. Let me just use my slide.
Are you not
So
able
when
to
I
zoom
opened
in?
the comment, when I opened my comment, this became smaller. So it's ocean energy. Thank you. It's ocean energy. I couldn't see that. The last one below wind energy. So ocean energy, now we're using the ocean current. Again, using the the ocean current, the waves to then drive turbines to then drive generators to produce electricity. However, if you look at ocean current, is not if you look at when it comes to our energy mix, Africa and South Africa as well, it's still a technology that we don't use as much as your wind and your solar. However, if you go to Europe, you know, in the north, you'll find that countries are starting to employ this energy as well, where we have ocean energy as part of the energy mix. And then moving on forward. And also, if you think of the age of Internet of Things, so we have Internet of Things, and then we have Internet of Industrial things. So that's controls the systems in the industrial setting. However, here it's about controlling systems in the domestic setting. Okay, Internet of Things, where we're using sensors, we're using electrical signals to control appliances. You're controlling your appliances at home while you're at work. Your lighting, perhaps you want to get home, rather you get home late so you can control that remotely. By the time you get home, your lights are on, it is heating. So this is all part of the smart home technology. So again, this then is founded on both software engineering and also electrical engineering. So electrical will be your sensors, will be your appliances and so forth, and software will be then the programming that will run that smart home technology or the smart home environment. Okay. And then biomedical engineering, we already touched on this. It's integration of biology and engineering. So you find mechanical and electrical. We did mention your prosthetics, even things like your pacemaker, your pacemakers rather, as well. It's part of biomedical engineering. So coming back to our discussion, you know, can anyone name something that they've used today that involves engineering, or anything that you are using now that involves engineering? Let me open the chat box again. Okay, this will become small, but it's fine. Uh,
I can
Driving.
read the comments to you, Mr.
Okay,
Nene, if
please
that
do.
helps. All right, so
Please do.
we've
Even though you
got.
sound soft. I'm not sure if it's my
Do I?
side. Wait, I think it's
Like,
my
can you
volume. It's
hear me
okay.
now?
It's my
Okay.
volume.
So
Sorry.
you've got two comments. So one is driving, the other is laptop.
Yes. So driving. That's correct. And driving, what engineering would be driving? That's a lot
That
to be
would be
honest, because
mechanical.
that's mechanical, and also you're
Yeah.
driving on what? On a road that is civil. You see, yeah. And then laptop, that's correct, Mr. Mafumo. I'm using a laptop. Some of us are using laptops, some of us are using cell phones. That's engineering. That's electrical, that's software, because remember, we are using platforms, to connect. So that's all part of what? Of your software. And your devices, electrical, electronics, electricity, that's correct. Our lights are on, electricity. And also, I'm speaking using these headphones or headsets. That's audio. So, audio engineering, which is also a subset of electrical. So, I'm using audio engineering. So, yeah, feel free
There
to
aren't
keep
any other
the discussion
comments.
going on. Yeah, it's fine. I'm moving. I'll just move on to the conclusion. But again, feel free to keep the discussions going. So, based on what we then went over, what do engineers really do? So, in essence, what they do is they identify challenges or problems, and then they investigate the cause, and then come up with solutions. So that's by designing the solution, and then evaluate and also refine them. And when they refine the solution, it will be through teamwork, and also doing comparative studies, analysis, and then from then they'll build models and prototype to test before then they take it out there. What they also do is also analyze and interpret data. So this is regarding maintenance. So after they design and build these systems they are running, then now and then they will come back, take data, analyze if they're still effective, if there is a way to improve them, and so forth. But most importantly, they ask questions. So it's very important to ask questions. I always say that's innovative. The only way to be innovative is to have questions. If you do not have questions, then you may not identify challenges or problems, and also you may not then bring solutions because you won't see problems. So engineers, you'll find them almost in every setting. So we, apart from engineers, which we call what your blue collars that are on the ground, that are building all the systems, we have also engineers in the research laboratories. So these are the engineers who will be dealing with your prototypes, your models. We even have engineers in your research and development centers, which are coming up with new technologies. And then we have engineers in power plants and also in industrial facilities and so forth. So engineers work in a variety offsetting. So that brings us to the conclusion of this webinar. So I'm not sure if there are any question or any comments. Let me just go back to the chat box because I see something was just posted. Okay, I think it's still the previous comment. Anyone else? Any comments? Any question? And I know that we will also then go back to the first question, Mrs. Matewu, if there aren't any comment.
Yes.
Any opportunity?
There is
Okay,
one.
yeah.
Yeah, so it says any opportunity that AI brings to engineering. So
Hmm.
basically, are there any opportunities that AI would bring to engineering?
Yeah, that's a good question from Mr. Mafumo. So, yeah, people are scared that AI will take their jobs, especially engineering. However, AI is a tool. So when it comes to engineering, I think it will take over when it comes to efficiency. However, you still need compliance to balance with efficiency. So that's where we come in. Compliance and also when it comes to environmental impacts, you still need the human side. However, AI will take care of things like your efficiency, optimization. So it will sort of make systems more efficient, more optimized. However, we still need human beings when it comes to ethical concerns, when it comes to environmental impact. So again, it's a tool. It's a tool, you know. Yeah.
Yeah. All right, Mr. Nene, let me just take control and just check. Um, so we are now heading to the question that we posed earlier. However, I haven't seen any participation, so I think we're just gonna skip over this and just continue with the presentation if that's okay with you.
Yeah. However, we have reached the end of the presentation, the conclusion.
Are we at the
So
end?
if there, yeah, so if there are no responses, then we can continue discussing. We still have some time.
Yes, but before we do that, we can just then go through our information slides. But just a reminder, if you guys didn't get a chance to scan the QR code at the beginning of the presentation, I have posed the question again in the Q&A chat box. So the question is, when you hear the word engineer, what is the first thing that comes to your mind? I mean, like Mr. Nene says, we will be continuing with the discussion, but if you want to answer this question, please feel free to do so in the chat box. So in front of you, you've got our upcoming webinars. So you'll see here we've got an open day that's coming up on the 22nd of August. This is an in-person event. You can please attend in our Midrand campus. The event will be taking place between 9 a.m. and 12 noon. Then our next webinar will be the protection and reliability in electronic systems. This will be taking place on the 26th of August. You can find all this information on our website. If you log in and you go under events, all the information of upcoming events will be displayed there. I'm now going to be displaying your certificate of attendance. This QR code you need to scan. It's going to take you to a survey that you need to complete, and then that will also lead you to your certificate of attendance. So while we display this, I'm just going to hand over to Mr. Nene so you guys can continue your discussion.
Yes.
Mr. Nene, there is something in the chat box. Would you like me to read it out for you, or do you have it covered?
The the question
Can you
that
hear me?
that was just, I can
Can,
hear you. The question that was just posted.
yes.
Yes.
The question that was just posted, it reads, if I graduate as an engineer here in South Africa, should I move overseas or should I stay here in South Africa? What are the career opportunities between South Africa as well as overseas? That is Europe, Australia, and USA. What is the comparison?
Great question. Thank you. So yeah, I know most people, in fact, it's not just engineering, even when you go to information technology, that's your IT, even careers in finances. There's this thing that, there are better opportunities, better pay overseas, they might, okay, there is truth to that. However, uh, I think this is the best time to be in the country and to be in a continent because um, I always say South Africa, although some people, or Africa rather, some people they're saying that um, we're developing, some they're saying we're a transitional continent. For me, I feel like we are yet to industrialize because if you look at of all continents, Africa is the least is industrialized continent. So for an engineer, it's yet to be an exciting time. Engineers, they love to create, they love to develop, they love to uh, come up with new ways of doing things. And Africa is at the time, you know. Um, it's even exciting in these transitions because as much as we wanted to industrialize, like how all other countries industrialize, using fossil fuels. However, with the change of the world, we're looking at climate change now. We want to transition to green energy, green economy, so which is something uh, that is still or something advent really, because if you look at your first world countries, they industrialized through fossil fuels. Okay, so their transition won't be as difficult as ours because they've already industrialized, they've already developed. It's just to be a matter of technologies. But for us, it will be more than just technology. It will be industrializing. It will be addressing challenges regarding electricity access, regarding electricity and energy security. So it will be a huge milestone. So again, it's a challenging time for Africa, and there's no better time than challenging times for engineers. So that's all I can say. This is the time to show our, you know, innovation, our talent, our skills. However, if you want to go overseas, you can go. But again, they've pretty much developed most of the things that they have. So I think it would depend what do you want as an engineer. So if you are more into challenge, if you are more into creating, starting new systems, technologies, then Africa is the place for you. Even investors are looking into Africa. Global investors are looking into Africa because there are opportunities, and also we are the youngest population. Uh, so yeah, so we're here to industrialize. What you see in your eastern countries, what's happening in the likes of your China and India, it's coming. The wave is coming this side. We are gonna be. Oh, already we are the youngest generation, by the way. So it will be exciting. That's all I can say. So again, this is my personal opinion. Yeah, I hope that answered the question.
Thank you, Mr. Nene. I don't see any other questions. Mr. Mafumo, are you covered? Okay, Mr. Mafumo is okay. He's happy with your answer. Is there anything
And
else
also,
that you would like to cover?
and also to add, you spoke about engineering entrepreneurship. That's where we will see that. We may complain about, obviously the challenges that we're facing. Perhaps we may say, okay, you are saying that we are at this challenging time. However, companies aren't hiring, or these state-owned entities aren't hiring, no, but this is the chance that opens then opportunities for entrepreneurship because again, as I've said, that now we are having this private public partnership. So that's where now you can even come as a private player, in developing these infrastructures. So yeah, I wanted to add that as well, since it's something that came up, engineering entrepreneurship.
All right, Mr. Mafuma says, so in other words, you are saying there are more opportunities for engineering entrepreneurship here in South Africa for growth than there are in overseas, in
Yes,
overseas.
Yes, I think the keyword is for growth because I can at this moment I cannot say that there are more engineering entrepreneurship in South Africa and Africa than overseas. But for growth, I can vouch that because as I've said, that for growth there are more opportunities. Remember, these challenges will bring growth. People will grow from these challenges that they're trying to solve. So for growth, definitely, because we are yet to build, whereas overseas they've already built. It's just a matter of maintaining and improving. But for us, it's a matter of starting things from the scratch. So, which will, you know, take your growth to the next level. So definitely, I think the keyword is for growth. Definitely.
All right, so
Thank you,
Mr.
Busi.
Mafuma is saying thank you, Mr. Nene. Just in addition, Mr. Mafuma is saying engineering entrepreneurship through fixing our problems. Thank you, great presentation. I think just
Thank you.
also in addition to the discussion is just a note to the students or to the attendees that are attending the webinar is that engineering is one of the scarce skills in South Africa. So there's a high shortage of qualified engineers. So I think it's important to study here for here. I think that also should
Yeah.
be something that's taken into cognizance when we are doing engineering studies, that Africa and South Africa needs qualified engineers. So I think before we consider moving elsewhere, let's just start at home. Let's fix our issues here at home and then consider
You
moving.
know, you
Uh,
know, I think you said it all when you said for here. For here.
yeah,
I know because some people might say that you are saying that we'll start afresh, start new systems, but really, if overseas, Europe and America have built system, why can't we then copy? We can't copy them because we will have to get solutions that are unique to Africa because we also face unique challenges. So which makes it even more
correct.
exciting. Yeah. So I think when you said for here, I think that said it all.
I covered it all.
Yeah.
Thank you, Mr. Nene. With that, also, I think we can just encourage people just to look into our college because we are also a specialized college, if you will, because our niche area is engineering, which makes us hyper-focused in engineering qualifications, and we give it all the attention that it needs. You've got your lecturers, like you see, Mr. Nene, who are highly specialized in their field. So if you want to be studying engineering, please look at our college. If you know anyone who's interested in engineering courses, again, please look at our college. That is the Engineering College of Science and Technology. Mr. Nene, if there's nothing else, I think we can conclude the presentation.
Yeah,
All
that's all.
right.
Thanks everyone for
Okay.
joining.
Thanks, everyone.
Thank you. Take care. Bye.